Hello. Hi, Joshua. How am I? I'm good. It's a good Sunday. Today really nice. Whole day like windy lah and cloudy and raining. Not so hot. I like it. Okay, so now let's look at electronic. Okay, tell you bad news. Start 5th of August. Means tomorrow. Mount on Block C will be closed. Means physics lab will be closed. So only Block B and Block E can be used. So I think 5 Santalia, you will need to close Block B. Later, let me check the timetable for Block Science Lab Block B because I need projector. Alright, electronic. This one, I think teaching school. Now we focus on number 3, which is called transistor. Okay. So, okay, page 150 first. Okay, so first of all, transistor. Actually, electronics means it's the part made up by semiconductor. Okay, semiconductor. Some say semi lah. Semiconductor means where's my periodic table? Here. Semiconductor means we are using them. Okay. So what's the advantage of semiconductor? Okay, of course lah, we say copper good is a good electrical conductor. Okay. Then this is none, means this is insulated. So semiconductor means semi-metal in between. So we can say it's half conductor. Then how do we make it into half? Most of the time we use silicon. Okay, silicon. So do you know Silicon Valley? Silicon. Oh, okay. So silicon normally we say is like crystal or silicon spatula. Okay, or Silicon Valley. Wow. Silicon Valley. So actually Google, Facebook, all are there. Okay. So electronics all about semiconductor. So chapter 3 we call it as electricity. Electricity we use all conductor. So what's the difference between electricity and electronic? Okay, someone said before, electricity means it will make someone die, like high voltage, to 250k volt. But electronic, they just need very small voltage, like 5 volts, like a charger. Okay, so this one, if gonna electric shock, electronic won't die. But if gonna electricity, yeah, it would die. So low current, low voltage. Okay, so now it's a transistor. So how to make it as Okay, how to make it as a semiconductor? Actually, we use these things. We use silicon. Silicon is the main material. Here. Silicon is the main material. So you can see this is group 14. Group 14 also means that outside got 4 electrons. So we say octet is the best, it's the most stable one, and is a gas. 8. 8 electron in the valence, 8 valence. Okay, so 4 means tetra. Okay, tetra. So we can say it's balanced, it's stable. We also can change it into not stable. Okay, how? For example, we doping silicon here. Okay, just like we're doping boron into silicon. See, boron is 3. Means outside got how many electron? Anyone can tell me outside of group 13 got how many electron? Thank you, back to me. 3. 1, 2, 3. Okay, so if we dop into the tetra, so we will get 1 empty electron here. So 1 empty electron here, we call it as hole. And we treat hole as positive. Okay, then, or if you so means lack of 1 positive. Lack of positive means this one will become positive. Lack of electron means this one become a positive. And then if you dot in 15, it will become negative. So 1, 2, 3, 4, 5. So for 1 extra electron means this is negative. So we say if this one got 3 electrons in the valence only, we call this as N-type semiconductor. Apa itu N-type? Negative type. Sorry. Lack of 1 means positive, so this is P-type positive. This is N-type. Okay. So now, never mind. We look at this. So what is a transistor? Transistor actually looks like this. Ta-da! Okay, if you learn RBT before, you will see this. Got 3 kaki. 1, 2, 3. 3 kaki, 3 legs. Okay. 3 kaki means what? Means we got 2 input and 1 output. Okay, and you can see ABC here. So actually, it's their name for the kaki. 3 kaki got 3 name. Kaki is the leg line. Okay, so C, B, E. B always at the center. Okay. So this is the circuit that we use in the remote controller. So since it's using silicon inside and the chip, or we say chip inside, so we can feel it's very light. Okay, so the advantage of using semiconductor, it will become very light. The all conductor, it will become very heavy lah. Okay, so this is some circuit here. Okay, so now let's look at transistor. There are 2 types of transistor. One called NPN, one called PNP. Apa dia? Apa? We just remember their name first. From top to bottom, no matter NPN or PNP, both of them, the top one, we call it as collector C. Remember just now what I showed you? CBE. CBE. C stand for collector. The center one, B, stand for base. So we also can say this is input. No, dun, 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 dun. You just remember CBE. E stand for emitter. Okay, collector base emitter. What's the difference? NPN, PNP is the way of current flow. Okay, so how to know NPN, PNP? Can you memorize the name first? C stand for collector, B stand for base, E stand for emitter. 30 seconds. Okay. CBE. You must be able to state their name so that when I mention it, you know, oh, which kaki am I mentioning? Okay, so now down here, don't look up. Let's draw. Transistor looks, first we draw a circle. Then on the left, we draw a vertical line. Then it's connected to B. Okay, then here we got two segment line, one up, one down. Okay, so up is C, down is E, so it's CBE. So C stand for yay, B stand for yay, E stand for yes. Thank you, Grace. Thank you, Bethany. Yay, yay, good. Okay, so I think the rest while you are looking at it, I believe you know their name lah. Okay, so now the problem is it's going up or going down. Okay, right? Let's draw two. Let's draw two. C, B, E. Okay, now one going down lah, one going up lah. Okay, so actually this arrow shows what? This arrow shows the direction of current. The arrow shows direction of current going down or going up. Okay, so now can you recall back? Current always flows from positive terminal to negative terminal. So same as in semiconductor. Okay. Yes, thank you, Aiden. So positive behind the arrow, negative in front of arrow. You agree lah? Towards arrow. Arrow towards negative. So arrow towards negative, this is N type of semiconductor. N type means negative type. So this one towards negative, this is N-type semiconductor, right? And then the transistor always like a sandwich, B as the filling of the sandwich. So since this is N, so sandwich, you know, two bread, N, so the center will be P. Current flows from P to N1. Okay, current flows from P to N. So PNP and NPN. Okay, can I get memorized now? Okay, and then I find out there is a pattern. So far in SPM, they never ask PNP. But if you do the question set from MRSM, or from SBP, yes, they always ask this. But so far in SPM, I just see this one only. And you can see most of the time, our textbook discuss the application. We only discuss NPN going down, the current going down, right? So Okay, now seems like you understand seems. Okay, no, never mind. You just remember the name first. Okay, now next, before we proceed, we need to know the function of transistor. Number one, this is the function, function one. Transistor as a current amplifier. What's the meaning of amplifier? Means it enlarge. Don't use the word enlarge. Yeah, increase or enlarge, yes. Amplify. Amplify. Actually, most of the time when we say amplifier, we will say amplifier of the sound. Okay, so it amplify the current. Why? It enlarge out the current. How? Okay, most of the time we connect it since it got three kaki. So we say this is input, IB and IC is input, and IE will be output. So we also can say IE equals to IB plus IC. Okay. And then you must remember one thing. Since you learn mathematical logic, so we say if in mathematical reasoning, you say if A then B, if P then Q. So here also, if IB, then IC. Means if no IB, then no IC. Apa ini? Okay, so since here got two input, so we can have two circuit on B and C. Okay, if the circuit connected to B, so that the current can flow through B. Current flows through base, we call it as IB, base current, right? The current flows through, so the way of current flows. Current flows through collector, we call it as IC, collector current. Okay, in exam, you can just write IB, IC, cannot. Okay, if you don't want to spell base current, you can just write IB. Okay, so IB plus IC equals to IE because they join back and then they flow back. So actually, how will it do? So IB comes here, IC comes here, and it will come back here one circuit and come back here one circuit. So we also call this circuit, here got two circuit. This circuit connected to IB, we call it as base circuit. 什么是 circuit？circuit 就是电路，电路就是那个电可以转一圈回去的 circuit. Means the current can flow through one circuit. So this is called circuit. So this circuit, we can call it as collector circuit, or we can call it as emitter circuit lah. Okay, collector circuit. But see lah. So collector circuit and emitter circuit. Is it separated? You can say they connected together. So can you say that for now, the current flows from here, join in IE, then it will split back to IB, and then IC, they will join back to IC. Yeah, so you can say they join back. Okay, IE will go through to for this arrangement. Okay, so we also can say that you can see base circuit normally low voltage, Collector circuit is high voltage. So this is low, this is high. That's why we can say if there is no IB, means let's say if I let this circuit open, not complete, no IB. So IC also will not flow. Okay, so it's like IB, we are using IB, and the voltage here, we call it as VB, base voltage. We use base voltage, switch on IB, then when there's IB, then only you got IC. So if you open the circuit, no IB, no IC. Get the rules. Okay. So what we have learned, collector, base, emitter. And emitter is output so far lah. So got IB, got IC. No IB, no IC. Even though you complete the circuit like this, you do not, you complete everything. But no IB, no IC. Okay, then normally IB is low voltage, so the current also low current. So this one high voltage, also high current. So we also can say we use a small voltage current to switch on high voltage current. So IC is bigger. IC is much more bigger than IB. Okay, then the amplification factor is better. Do not worry, exam is given. Ta-da! Electronics. Okay, so this is under the thermionic emission. It's here. So we use IC divided by IB. IC divided by IB, then we know like how much times the current is amplified. So actually it's like your enlargement, transformation enlargement. K equals to PA prime divided by PA. Enlargement factor, amplification factor. Okay, now like test yourself. If IC is 10 milliampere, IC is 100 microampere. Can you please tell me what is the amplification factor? I press your calculator and tell me. Didn't. 100. Thank you very much. Is it 100? So it will be 0.01 divided by 0.103. Yeah, 100. Okay. So anyone still not sure? So the factor will be 100 under unit because it's a factor. It's a ratio. Everyone know how to press milli and micro? Anyone not sure? If not sure, I teach now very fast. Okay, no one settle. Okay, so now IC divided by B lah. Okay, so now this is current amplifier lah. So small voltage light up, open up the large voltage circuit. So where do we apply our car engine? Okay, so actually when we start engine, now it's press button. The old type one is using car key. So actually the car key might just our car battery is 12 volts. DC, it's a very high voltage. Because DC, high voltage, high current. So if you directly touch on the circuit, you might get electric shock. Okay, so we use a small voltage, maybe 1.5 to 3 volts of the small battery. We light up the car engine in 12 volts of DC. Okay, so now next. Second, function of transistor as an automatic switch. Switch on, switch off, automatic, they will detect. Okay, so for example, switch on the light when it's dark. So see LED, dark. Switch on the alarm when it's too hot. Okay, so now what's the similarities between these two things? We always put the things you want to switch on to the collector circuit. Okay, to the collector circuit. Okay, collector circuit CBE. CBE. Okay, and this is the sensor. So this sensor called LDR. What is LDR? This is bahasa lah. We look at LDR, light dependent resistor. It is one of the sensor. So this sensor we call it as thermistor. Thermistor sensor. Okay. So here is some sensor. Actually, there are many sensors. Okay, where's my sensor? Sensor. Just save the sensor. Yeah, for example, the sensor like this. Okay, actually here got around 25 different types of sense. Like this. I thought I saved. Okay, where is it? Oh, I saved it. 5 sense. So we just discussed these two. One is LDR, light dependent resistance. Another one is thermistor, temperature sensor. Others is like the rain sensor. We don't discuss like alcohol sensor, color sensor, gas sensor, smoke sensor, soil moisture sensor, photo transmitter, touch sensor, humidity sensor. Heartbeat, water flow. Okay, this is good if your house always got if you're scared got leaking problem or what, or flood, I can put this. So far we just look at these two only. Okay, light sensor. So the light sensor, it looks like this LDR. LDR looks like this, very small, a bit smaller than your fingernail. All right, looks like this. And this is, normally you also cannot see that it's hiding inside the cap, the box. Very small only. My house also, I put on this sensor. So when it's dark, it will light up itself. My house, I got two. One is I set the clock one. This one is another type. Okay. And this is the symbol. This arrow shows light. When the light touch on the resistance, it will change the resistance. Okay, or sometimes you can see above the straight light or something like this. It will sense the light. How does the sensor work? Yeah, we are going to discuss this. Okay, so now, what's the difference between this circuit and these two circuits? Okay, this circuit, we got two battery. So we just want to amplify. So amplify means we use one circuit, small voltage circuit, control, switch on large circuit, large voltage circuit. This one, see, we modified it. This one don't have the top part, but this two, we have the top part. Then we can see we only have one battery source. Okay. So now how to control B? So same thing as these two. You set the condition when there is IB, then only you switch on IC. When there is IB, then only you switch on IC. Okay, so now, how is it work? Okay, for these two, let's memorize two things. For LDR, please remember BL. For thermistor, please remember HL. Okay. Do you know what's BL? Okay, actually BL stands for bright low. Okay. I think some people will also know BL stands for other things. Or you can Google later. Okay, then HL. HL stands for hot low. Low resistance. Then you can see that actually LDR we put on the bottom, then thermistor we put on the top. Okay, why? Okay, because we want to switch on, we need to have high voltage at the bottom. Okay, so actually there are many types of LDR, but in Form 5 we just learn bright low only. Many types of thermistor, in Form 5 we just learn hot low, okay? Okay, now let's see how will the current flows. Okay, let's say when the switch is on, okay, wait a minute. Yeah, okay. Okay, when the switch is on, so the current will start to flow from positive to here. What do you think? Will the current go down first? Okay, where will the current go? Go down or go left? Like 1 or 2. Go down or go left? The current, just guess. Go both. Oh, okay, got one more. Both. Thank you, Grace. Thank you, Dylan. Thank you, Bethany. Can I have 2 more percent? Thank you, Aiden. Thank you, Jinya. Okay, yeah, good, correct. Yeah, actually, go left first. Huh? Why? Because if there is no IB, no IC. No IB, no IC. So it means what? If it goes down, ta-da, now it's IC already. No, not yet. Because no IB yet. So there's normal I, so it won't go down. Go to here. When it pass through here. By the way, this one we call it as a junction. Can you see the junction? Junction means the circuit will have 2 different direction. They can choose that go to different direction. So we call this point as a junction, T junction, like a T junction. So we call this as junction. When the current comes to the junction, they will choose either go straight, go left, or go both, right? So this one, they just go straight because no IC, no IB, no IC. Now, they will choose. They want to go in here, means it will make an IB, or it will go down to LDR. Okay, so depends on, so current is like human now. So when got high resistance, they won't go. So now let's say it is since bright low. Okay, so means now if bright low means daytime. Daytime means low resistance. It will go down. Okay, compare to this. Here got 2 resistance. This one we call it as RB. This one we call it as resistance for voltage. This part, remember this part we call it as base circuit. So this base circuit depends on resistance. If low resistance means low voltage, because V equals to IR is DC. It's DC. Okay, V equals to IR. Yeah. So it goes down and it will not go back lah because it's reverse bias. Current should go down, cannot go back. So go and come back. Means, will the light falls through IC? No, not in the daytime. Okay, daytime. So now comes to the nighttime. Comes to the nighttime. Nighttime, so since BL means bright low, so means dark will be high resistance. Up to you lah, you want to remember this or not. You just need to remember bright low means dark high. So HL means hot low, means normal or cold. Cold or normal is high. Okay. Now look at this. Nighttime means dark time. Dark time, like the current comes out from positive and reach the junction. Can you tell me the current will go now the dark timer. The current will go down, go left, or go both. Thank you, Bethany. Thank you, Dylan. Thank you, Aiden. Okay. Yeah lah, correct lah. Actually now it will be light up, but not yet. Not yet reach ID yet, so it will goes to the left first. Yeah, take corner goes down. Now comes the junction, they choose again. Now it's dark. Dark means Now this resistance is high. This resistance is higher than RB, so high resistance. Don't want to go, so I go B. Ta-da! So now we got IB. So when there's IB switch on, then there's IC. Then they meet together in SIE and come back. Then nighttime switch on. Okay, let's exam normally will ask how is it switch on. Now let's look at the page. Let's write the sentence to describe how to switch on. Okay, let's look at this. Look at this. Mana dia? Okay, this one. Page 165, like page 165. Okay, like page 165. Okay, page 165. I feel this is annoying. Can you use a sticky note or a paper, just paste it down? And you just rub it off or paste it. Use a paper can. I feel annoying. The sentence not simplify enough. Okay, right? Use a paper or a sticky notes. Rub them. I mean, you just paste on them. Okay. Tell you the shortest sentence so that you easily remember. Okay, then this one is a bahasa, you cancel. LED means light emitting diode. Actually, they draw me. Okay, let's draw one circuit, same circuit, exactly the same circuit. We always start from center, like center. I mean, this is a transistor going down. Okay. Then here is LED. This is a light bulb. Okay, so 6 volt. Actually, one battery 1.5. So if you don't want to write, if you don't want to draw 4, you can just make a dot. You 6 volt. Get it? It's like maths lah. Like maths. A, B, C, Z. Something like. Okay, then we make it like this. Actually, LDR means it's a resistance. Just that it depends on the light shines on it. So the circle here is the cover, okay, to protect the LDR inside. So 2 arrow here means light, how much light. So this is LDR. Okay. So this is 10K ohm. This is LED. is a switch. It's good that you draw it out. You will understand better. Okay, like next. This one is daytime. This one is nighttime. Daytime means bright. BL. BL means bright. Low resistance. And it's bright, low resistance. Nighttime is terbalik lah. So I prefer to memorize one only lah. One for each. So nighttime would be dark. Since it's bright low, so dark means it will be high resistance. Okay, and here is DC. DC means V equals to IR. So the resistance will directly proportional to voltage. So low resistance means low voltage. What kind of voltage? Still remember the circuit here name is base voltage. So we say low VB. Low resistance here down here means low VB. High resistance here means high VB. This part, the bottom part is B. Okay, like now. You can use a red pen to draw lah. During daytime, the current flows out here to reach the junction. Current. It will not go down because no IB, no IC. So no IB, then no IC. If there's no IB, there's no IC. It will go straight until this corner. Sorry, this junction. This is the junction. Then the current will choose lah. Which one low resistance? I go there lah. Same like us lah. Oh, got shortcut. Yes, let's go shortcut. So now, during daytime, it will be low resistance. So we say low resistance. Let's draw a voltmeter here. So this one would be low lah. Low VB lah. So low VB means what? Means yes. Here shortcut. Go here. And come back. This one you should connect it. Should connect properly. Okay, so daytime not light up lah because no IB, no IC. Okay, let's draw. Let's figure out the sentence. Okay, number one. Number one. Actually, the switch always on. We don't close one. Number one, we say that during daytime at this and LDR, light dependent resistance has low resistance. Okay. First you mention this because LDR is our sensor. We mention our sensors. Okay, then next. So LDR low resistance means VB is low. So we say base voltage. So base voltage is low. So number three, base voltage is low means the base voltage cannot switch on the IB. IB base current. You can write IB. Something wrong somewhere. Yeah. They cannot. Okay, cannot switch on the base current, or we can say it is IB. That is IB. So cannot switch on IB means what? Means the LED will not be light up. Okay. Actually, here, if you want to say VB is low, can. So cannot no base current. Okay, finish already. This is daytime. Okay. Okay, so now next the sentence will be the same. Sorry, I did a stupid mistake. So actually you can copy all of the sentence here. You can copy all of the sentence here. And now come to night time. Dark higher. So here let's draw. Sorry. Okay. Ew. Okay, let's draw a voltmeter here. VB. This is VB. So nighttime high resistance means VB is higher. Okay, high resistance. Okay, so during night time, so we'll change to during night time. It is dark. Means LDR has low resistance. High resistance. When high resistance or base voltage is high, so the base voltage now can high enough to switch on the base current IB. So, yeah, I forgot just now. Base current. I forgot one more. I forgot. One more sentence. Okay, can switch on the base current. So collector current flows now. And collector current flows means LED light up. Okay, yeah, just now I forgot. Cannot switch on the base current means no base current, no base current, no collector current. That's why we always put something we want to switch on in collector circuit, above collector. Okay. Now do you get the pattern? Very short. Okay, for number 1, we say dark LDR is high resistance. So BL means bright low, dark high. Bright low, dark high. Okay, dark high. Then base voltage is high. Base voltage is high. When base voltage is high, then it will switch on IB. When switch on IB, there is IC. So finally, LED light. Can see that 4 marks, 1 marks, 2 marks, 3 marks, 4 marks. In exam, can you use VB, IB, IC? No problem. Anyway, when I teach, I must tell you the full words lah. Okay, the full words. Okay, very easy, right? And must remember, LDR must put at the bottom. Okay, this is how we control to switch on. Okay, now let's look at thermistor. So now if the balik, this is the balik, we ignore them first. The balik, okay, very fast. If you the balik, you put on top. If you put on bottom, daytime, it's not light up. It's not light up. But if you put on top, means daytime, it will light up. Okay, the balik. So remember, LDR always at the bottom. I never see question asked on top lah. Never see lah. So as long as you can remember at the bottom, good enough already. Now look at this page 166. 166. Thermistor. Transistor as a heat or temperature control switch. Okay, same thing. Hope later I won't make stupid mistake. Hope I won't make stupid mistake. Okay. Ignore all of this. Just tell you the simplest sentence. Use sticky notes or paper. Just stay on top. Any paper will make mistake later. Okay, so now, please redraw it. Okay, redraw it. You can make it bigger. So this is a transistor. I make the line thinner. This is a transistor. Always going down. This is CBE. So To the left, got battery, 12 volts. To the right, on top is transistor. This, like this. So this is a transistor. How to draw? Actually, it's a resistance, but you add a line like that, like a 7 here. Okay, 1 kilo ohm. This is R. You name it as R2 lah. Okay, you name it as R2. So here is R3, 1 k ohm, R3. And then here, sorry, I cannot rub, you rub yourself. Here is something like this. Apa ini? You draw first. This is alarm. This is a relay switch. Is that a relay switch? Yes, it's a relay switch. Oh, like this. Okay. What is a relay switch? Relay. Relay. What is a switch? The relay switch is a switch by using electromagnet. Relay switch. The last time, now also digital already, electronic already. Relay switch circuit. Now also using the very simple one already. Relay switch. Relay switch. Now relay is like an electronic things already. How it works. So you can see that same thing. First circuit, second circuit. Normally we connect first circuit. Okay, this first circuit will be IC. Sorry, no. Okay, look at this part. Can you see the contact? Okay, so when it works like this, when the current flows in, this becomes CCC. CCC means it will have magnetic flux. So this one will turn into magnetic flux and attract the contact. When they are attracting, means second circuit switch on. So this is another type of safety precaution. We use one circuit switch on another high voltage circuit. Okay, so this is called the relay. Now like that, you see that. When there's IB, then there's IC. Switch on, see? The motor will turn on now. Now this is the transistor. Don't ask why got two. You are learning next stage. Now we learn one only. Okay, so Okay, so relay is when there's IB, relay will on and switch on another circuit. Okay, now relay, see, the relay will switch on. Okay, so now, thermistor. What's the thermistor is HL. Okay, so it means HL here. HL. HL means hot, low resistance for thermistor. Low resistance. Okay, so hot, low. So remember BL, bright low, and hot low. So this one will be cold or normal. Cold means high resistance. Okay, let's draw the circuit. The current come out here. It won't flows down because it's an open circuit. So now goes here. Okay, question. Now the current will goes to the left or goes down or now goes both. 1, 2, 3. Now in this junction, the current, what will the current do? Okay, just answer. Down because high. No, no. No, no. No, no. Okay, thank you. Thank you, Bethany, Chen, Joe, Bethany. No, no. Okay, same thing. Actually, now is the beginning, so the current will continue go straight. Ha 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 ha. No IB, no IC, not yet IB. So now go down. So now can you see high resistance? Too high. So means what? Means this one too high. Because thermistor we put on top, right? Thermistor we put on top. So this V we call up is 1 now, V1 now. Okay, so R1. This is too high. Okay, means what? Means current stop here. Okay, current stop here. Resistance too high, the current cannot pass. Okay, now during hot time, low resistance. Okay, so now right, current goes here. It will not go up, go down because it's an open circuit and comes to here. And I believe now you get the idea. It will go straight. Yes, because no IB yet. So now this one hot, low resistance already. So low resistance, like V1. So we say low resistance means low voltage up here. So it will go down. Ha ha ha. Now comes to the junction. Okay, it comes to the junction, even though these two are both 1 kilovolt. But now this will go into IB. Why? Because now VB is here. So this VB always at the bottom. Okay, the VB goes in. Yeah, then there's IB, there's IC. When there's IC, then the relay will be direct and closed. When it's closed, the current will also flows into the alarm. and come back. Bang! Okay, so of course here continue, goes down as IE, then come back here. Since this is low, so now this baby is high. But what am I talking about? You just remember current got IB, IC. Let's say that if you forget, what is BL, what is HL? As long as you want to say it's ringing, as long as you say there's IB, there's IC, alarm ring. Too much already. Understand? If you want to say it rings, just remember there's IB, IC, alarm ring. In front you forget, never mind. At least you write IB, IC, alarm ring. Like this one. You forget, how resistance? Never mind. IB, IC, LED light up. Okay, at least 2 marks, right? Okay, let's write the sentence. Okay, like number 1. When it is hot, thermistor is HL, hot, low resistance. Okay. So when thermistor has low resistance, okay, so we can say that whatever your second, you know it will be triggered, it will be switched on. So whatever your second sentence, always say base voltage is so now base voltage switch on a base current, and we say since there's base current, we say collector current flows. Collector current flows means flows through the thing you want to switch on. So when it flows, then you say, if you want to say relay switch is on, alarm is ring, you don't want also never mind. So we say relay switch is on and alarm start moving. So get the idea? No matter in front, okay, you just start second sentence. Base voltage is high, so you switch on base current. When there's base current, there is collector current. If you forget number 1, at least you get 3 marks. Very easy, this kind of question. At least you get 3. Okay, but if you can remember this HL, hot low, when it's hot, thermistor has low resistance, 4 marks. Okay. Same thing lah. Normally they won't ask you why it is not on. They will ask you why it's on. So same thing lah, why it is not on? Because when it is cold, thermistor has high resistance. So base voltage is low. As long as not on, base voltage low. Base voltage cannot switch on base current. So no base current, collector current not flow. So not flow, so relay switch is off. Alarm stay silent. Normally this three only lah. Okay. So now okay, now look at page 170. You can see lah, here is microammeter, this is milliammeter. And then what they are asking you, what is the amplification factor? So amplification factor here, beta equals to IC over IB. So beta equals to IC, larger, okay, IC. This is IC, always larger than IB. So the reading of microammeter is IB. The reading of milliammeter is IC. So 1 milliampere divided by 10 microampere. What is the answer, right? Yay, thank you. 100. Yeah, I think you terbalik IC. Okay, teacher, can you teach how to calculate? I want to ask just now. Oh, okay, here. Very easy. What kind of calculator do you have? Are you using this or this? EX or MS? Class with EX or MS? EX or MS? EX. Oh, okay. EX. Oh, I just learned. Very easy. You just press. Now, this one is 1 milli divided by 10 micro. Okay, so it will be 1 milli divided by 1 micro. So you press lah 1 option. Then you will see number 3 is engineer symbol. Press lah number 3. Then you will see, wow, a lot of prefixes. Please choose M. M is number what? M is number what? What's the number for milli? 1. Thank you. So you press 1 now. So you press 1 first. Then you press option 3, 1 again. You will get milli. Then you press divided by 10 micro. 10. Then you press again, option engineering symbol. Milli is 6, is it? Yes, I mean micro is 6, is it? Micro is 2. Oh, thank you. 2 is micro. I press 2 lah. Then you will get this. Then you press equal sign again, you will get 100. Okay. Okay, Ajo. Yes, yay. Let me check. Is there how to use engineering symbol in Casio EX? Take this one. Yeah. So you just press option 3. Then you will get all of the list. Save image. Calculator. Where's my Chile is US and engineering. Okay, so now let's count. So emitter current IE. So actually IE, this is not given our formula. IE equals to IB plus IC lah. IE equals to IB plus IC lah. So same thing, you just write 1 milli plus 10 micro. You'll get, this is plus lah, just now divide lah. I believe you can get that, right? Okay, so now this one. Circuit emergency of alarm. Okay, so alarm normally means fire. Fire means hot lah. So now, without referring, can you please tell which one is the best? 1 minute. We want to detect hot, not light, but hot. Hot. Thank you, Biden. Thank you, Betty. Thank you, Grace. Thank you, Ethan. Thank you, Joanne. Yeah. X, correct. Why like, okay, we always, my fault, we always read here, got relay switch. Yeah, got already. Now, please read here. Find the criteria so that we won't write as reason. So you're prior to determine the suitable set of electronic component function as emergency alarm. Study the type of electronic, explain the component, determine the suitable. Oh, I like this kind of question when they are suitable. It will not limit your reason, whatever reason can be. Okay, so now, why we chose this? Apa ini? So if in the exam, I forgot what name is it, you can draw it up. Yeah. So remember your 10 marks question, please make table. Okay. Yeah. So number 1 is, yeah, I forgot. You just draw it back. Yeah, just draw it back. If you forgot the name, just draw it back. But if you remember the name, very good. No need to draw. Just say Transistor. Yeah. Okay. In case, just in case. Okay. Do not panic. So, okay. Terminal P. Sorry. This is normally we say terminal P. Then thermistor we write here thermistor. And we write here reason. This is characteristic. This is your choice, and this is your reason. Why thermistor? To detect heat during fire. Or you can use back the characteristic just now we mentioned. Hot low, HL, hot low. So when it is hot, thermistor, or you say has low resistance. Hot low to detect heat, to detect hot. It's a sensor, as a sensor to detect heat. Something like. Okay, now next. Why this one? So this, so you can write. We can see just now if we draw. Just now when we draw, we can remember someone. So this is called RP. Okay, so components. This is PQRS. So this is Q. 1, 2, 3, 4, 5. So it is a resistor. This is a resistor. Means perintang. Perintang. You all learn in RBT. Perintang. Ta-da! Perintang. Alright, resistor. Okay, resistor. So actually the name is RB. Base resistor. Base resistor. Why? Because to limit or to control. Normally we say limit the IB, the base current. You want to write IB also can. Because it's a semiconductor, if the current too high, it will burn. Right? Normally it's to limit only. Then now, why alarm? So that alarm, alarm. This is our alarm. Because alarm can make a big sound to big sound and can diffract sound wave, remember? Diffract and penetrate. Diffract and penetrate through building. If LED, this is LED. Can you see the light go out? This one is the light go in. This one is keep up the light go out. If LED, die lah, because the LED cannot pass through the building. We cannot see. Okay, so big sound can diffract and penetrate through building. Big sound or sound waves. Okay, next. Since 1, 2, 3 already, of course, this lah. Then why battery like that? So battery, how we describe this kind of battery? Now we put battery here so that the battery can flow through IC and flow through IB. So if you terbalik, see if you terbalik, then cannot go. Okay, so we must put it like this. How to describe like this? We say connect positive. This is called terminal. Connect positive terminal. Terminal means from battery, positive side from battery to collector circuit. And then, okay. Normally, up and down only got C and E. We normally say connected to C or connected to E. So we just say connector to collector circuit then. Okay, or we can say connect positive terminal to this is PNP. Sorry, PNPN. Sorry. No, just to collector circuit enough. Okay, just collector circuit enough. Okay, so reason is so that it is forward bias. Apa itu bias? Bias means current can go forward lah. Can see that go forward. And reverse means reverse cannot pass through. Okay, so it's a forward bias. Or we say so that IC can flow, or so that IB and IC can flow. So if you pasang terbalik, no IB, no IC, so that IB and IC can flow. Okay. Well, go forward no matter what. Can say that lah. Well, go forward lah. Okay, so this is SPM question. I think this is SPM 2018. Yeah, 2018. Yeah, 2018. Plus 2. I invigilate. Oh, no. I bertugas. Yeah. 2018. Okay, so the rest, same thing lah, see. Page 173, what they ask? They ask, this is a switch for LED. It's a switch. Okay, you are assigned to produce an aircon able to keep temperature low in factory. Yeah, suggest a suitable modification so that aircon can be switched on when temperature increases. Okay, so now, apa ini? We got LDR, is a light. And now we want to change the temperature, and so we change the thermistor. So just now you compare, or you can directly draw one more. So we want to change like this. Transistor still the same. Transistor still the same. Transistor still the same. This is CBE. Remember to put resistor here to limit IB. So now we change to thermistor, put on top, thermistor put on top. And down here we put a normal resistor. Where is aircon? Aircon here. Aircon high voltage one. So maybe we can make relay switch. Okay, we can make a relay switch. So relay switch and aircon, just say air. Okay, thermistor put on top, 4.5 bar. Okay, 4.5. Thermistor on top, LDR at the bottom. So when you fix one changing, another one always constant. If you put up, we call R1. If you put down, we call R2. Okay? Now, so I think the rest you all can do already. That's why just now I asked you to start from center. Then, if you are not sure, just copy answer. Alright, try copy answer. And what else? Okay, here come to the page 169. Okay, here 169. There's a calculation about V and R. Okay, so now first of all, we need to know what is a potential divider. Actually, it is in this page lah, but I feel the diagram a little bit confusing. Actually, it's here, 162. But I find out it's a little bit makes you confused. So I directly use 169. Okay, we use this. Okay, what is the meaning of potential divider? We can treat it as voltage. Potential means potential difference. Voltage divider. Okay, so now this one. Now if we rotate 90 degrees, we ignore here. Ignore. And you don't draw, I draw there. We ignore this. But now please draw. Rotate 90 degrees to the left. Let's draw. It's 12 volts. It's 12 volts. R1, R2. So this is 40 kilo ohm. This is 10 kilo ohm. Okay, so now, according to DC rules, V equals to IR. So actually here we got V, we got R, we say V directly proportional to R. Means if your R increase, your voltage will divided into higher portion. Okay, so what is the meaning of parallel? You can see here the beginning of battery to the end of battery, totally 12 volts. And then here, these two parallel means total here 12 volts, total here also 12 volts. So now actually 12 volts will be divided into two parts, part 1 and part 2, okay? So actually it's like this, just we switch 90 degrees, okay? Now, part 1, part 2. So we can say part 1 is 40 kilo portions. Part 2, 10 portions. 10K portions. So totally got how many portions? Totally we will get 50K portion. 50K portions. Alright, 50K portions. So it's quite easy, like if you apply proportional method in a library, we got 10,000 books, okay? If the ratio of novel to fiction, novel to reference book is is 3 to 2. Can you please tell me novel got how many books? What do you do? So I believe you will do this. Novel equals to total 5 portion. Novel 3 portion times 10,000 books. So you will get 3 out of 5 times 10,000. Okay, so 515, 6,000 books. Same thing as here. Okay, same thing as here. So what is the portion for R1? So the voltage here, so actually 12 volts will be divided into two portions, sorry, two parts, 50K portion. So now what is your V1 and what is your V2? Okay, we say V1 equals to, can you see a portion times total? Total is 12 volts. So the portion is 50K because 40K plus 10K. So, and then V1 got how many portions? Like novel got 3 parts, 3 portions. So we put on top 3. So same thing as here, 40K times 12. So so we will get 515，520，5四20，所以4416，428.9volt. So what is V2? V2 is a fraction times total. So what is the fraction? Total portion will be 50K. So this is 10K lah. Then we 5 5 5 5 5 5 5 5 5 5 5 5 5 5 5 5 5 5 5 5 5 5 5 5 5 5 5 5 5 5 5 5 5 5 5 5 5 So if 9.6 plus 2.4 total up 12 volts. You see that? So now 12 volts will be divided into two parts, 9.6 volts and 2.4 volts. Teacher, what is K? Kilo volt, kilo ohm, sorry. Kilo ohm, kilo, thousand. 40,000. I lazy to write 30, so I always write K. I remind myself K is 1,000. I lazy person. You suppose write in this way. You suppose write 40,000 on 50,000 on K. But I lazy. I put K. Can I do this in the exam? Can or not? Can. As long as you remember the K is 1,000. Can. So, see, this is called potential divider. The voltage is divided into two parts, 50K portion. 12 volts is divided into two parts, 50K portions. Understand? Potential divided. Now, so determine the potential difference across R1 and R2. Means V1 and V2. So same thing. V1. So the formula is this. Sorry. The formula is like this. V, nothing means no. So V1 means R1 divided by R1 plus R2. V2 means R2 divided by R1 plus R2 times total. Yeah, this formula not given. You can write here. Okay, so number 4 and number 5. Potential divided. V1 equals to something times total V. This thing is R1 divided by R1 plus R2. Is this for chapter 3 also? Chapter 3. Yes, can. Yes. Can use can. If your chapter 3 you see this, you see parallel but got two resistance. Yes, you can use it in chapter 3 too. So here got two lah. Here got two lah. So remember, add these two in your formula list. Okay, so now calculate the total resistance between point X and Z, and the current flows X. Where is X? X is here, Z is here. So total resistance 50K, 50 kilo ohm. So what's the current? So since this is DC, we can use V equals to IR. So V, see, X to Z means see these two parallel. So is 12 equals to I times R is 50k ohm. 50k, remember, 1000. So it's I equals to 12 divided by 50k ohm. Divided by 50k. 0.00024. 0.00024 ampere. See, very small, right? Not even 1 ampere. It's less than. It's around 10,000 times lesser than 1 ampere. Okay, then exam, normally how they ask, you can see lah here. Chana, like number 1, page 168. They are asking what is RT. Actually, it's this lah. I think they write something wrong. RT means R for transistor. So this one should be RT lah. So actually, you turn 90 degrees. Or if you feel, wow, it's hard to see, you redraw. You redraw 12 volts. Ignore the center because they want you to calculate. So we use potential divider. You redraw. Okay, at the end, this is a thermistor. This is a thermistor. This is a resistance. Normally, I would say top is R1, down is R2. For me, I would name it myself. And RT don't have. Okay, maybe I will write like this. RT is a question mark. This is R2, 20k ohm. So let's draw. This is VT, voltage here, and then this is V2. Okay, VT 2 volts, V2 10 volts. So now 12 volts is divided into 2 parts. 2 volts, 10 volts. So since we want RT, so we can say that RT equals to a fraction times total volts. Hey, sorry. My fault. I'm sorry. V. Formula. V equals to a fraction times V. Vt equals to a fraction times total V. So this fraction will be RT, the proportion RT divided by RT plus R2. I will name it as 2, whatever is it. So Vt, so like substitute lah. Vt we have or not? Yes, we have, so 2. RT we don't have. RT we don't have. But R2 we have, yes, 20k ohm. K means 1000, Remind yourself. If you're lazy, you don't want to write 20,000. You can write K. But remind yourself, it's 1000. Times total V is 12 lah. Then, how to do? Please use your linear equation. Okay, if you know, you can do lah. Okay, if you don't know, you follow me lah. Okay, so this is 2, this is 12. We move to another side first. 2 over 12 equals to RT divided by RT plus 20k. For me, I like to make it in fraction, okay, so I will get 6 of t RT plus 20k. Or if you feel our T is very, you just say R1 to you. Okay, so now 20k equals to 减掉，这个是 1RT 减掉 2RT. So RT equals to 20k divided by 5. RT equals to 4k ohm. Got it? Get it? Yes, mission complete 9:30. Okay, so let's make a revision. Let's make a summary very quick. Two formula not given. One is IE equals to IB plus IC input plus input equals to output. Okay, then be careful. Normally they give milliampere, microampere. Milliampere actually bigger. Bigger is IC. Microampere is smaller. Smaller is IB. And then potential divider means actually we divide 12 volts into 2 parts, a few portions. So for this case, it would be 24k portions. Right? As long as you can count this, and then you know how, you just remember the on circuit. Just remember the on circuit. Okay. For LDR at the bottom, transistor on top. How to describe them? If possible, remember HL hot low for transistor, bright low for LDR. Then after that, you can see 2, 3, 4, the same thing. High base voltage, base current flow, collector current flows. VB increase, IB flow, IC flow. You get 3 marks. If you can remember HL and BL, see, same thing, 2, 3, 4. Then if you can draw out, not the problem for you lah. Transistor always on top lah. Same, always the same thing. Quite easy lah. Quite easy means the format fixed already. They won't simply change. So that's the easy part lah. Okay, still got any other question? If got question, you can stay back lah. If no questions, you can go rest lah. Thank you very much, everyone. Bye-bye. Bye. Welcome.